things from here on will be recorded. All right. So I'm glad to see people are streaming in. And I am just checking on my YouTube side. Yep, it is online. Okay, very good. And according to YouTube, we have, besides myself, there should be one more person watching it from YouTube. Okay, that's fine. I am going to close that window because I just needed to confirm that it is working on YouTube as well. Alright, so that part is done. So as I said a little bit earlier, for those of you who just joined us, I'm here a little early, so if you have any questions, you can go ahead and ask your questions. You can ask your questions using voice, or you can type it in the text channel, or you can also direct message me in Discord. So all of those are ways to interact with me and potentially interact with the class as well. Alrighty, we got a few people typing. That's usually a good sign. Hello, hi Danny, how are you? I'm good. I'm good. I'm ready for this class. Alright, excellent. Okay, so I got a few direct messages. I think that's because some people did not change their nickname, so I'm gonna go to the members of the YouTube channel one last time and change the row of people who have just entered their nicknames correctly. Yep, that's one right there. And I got a few people who still have not changed their nicknames. One is Orange Pomegranate. One is Kirby64, KRBY64. And one is ARC Discord. So unfortunately, if those people do not change their nickname, they won't have the role changed to a student role. Alright, so it just got one resolved. Okay, very good. And we got about 1 minute before the class starts. I think I got some cat fur, stuck on my on the windscreen of my mic, and it's touching my chin, so it's kind of itchy. Well, as long as it's dry, it won't gunk it up. You just need a yep. You just need to get some compressed air and blow it out. Oh, neat. Yeah, those are really good. Some are really loud. I like those. Yep. Well, it's good for people who type a lot. For some people who do not type a whole lot because they like to do everything through the GUI interface, then having a nice keyboard doesn't really help. And for gamers, they don't really need a whole keyboard. They just need, what, 9, 10 keys? Chat. Yeah, I'm gonna start a off-topic channel after this class so that you guys can put in all kinds of stuff over there. Alright, well, it is noontime, and I am going to get started here. So a few things, before I actually get to the class content. The syllabus is already discussed in a separate video, so I highly recommend everybody in this class to read it as soon as possible, certainly before the next class meeting on Monday. But I do want to kind of go over this little note here that I have typed in Joplin. It is on required resources. And Joplin allows you to change the screen so that you can hide this portion away. And there are shortcut keys. I cannot remember the shortcut keys anymore. Let's see, toggle layout. Okay, Control L. There we go. So Control L, and there we go. So this is just I think it's still editable. Nope, it is not. So this one is only viewable, so this way I can use more of the screen to view the content. And I have used the dark theme in Joplin. If that is bothering people, I can kind of switch back to a light theme. So the first thing I want to go over, this is actually just the that's not what I want. There we go. Okay, so this is the rendered HTML instead of the markdown version of this same text here. So okay, one of the more important point is what exactly is 1 unit. Okay, because if you don't know what 1 unit really means by now, well, I'm gonna let you know. So 1 unit, 1 lecture unit, in a class means 16 hours of lecture over the entire semester, or whatever the duration of the class is. Now the important point is there's an assumption. Okay, the assumption is for each hour in lecture, students would be spending 2 additional hours outside of lecture in terms of reading the textbook, watching the recorded videos, reviewing their own notes, doing homework, studying, and so on and so forth. Okay, so the ratio is supposed to be 1 to 2. And this is only for 1 unit. Okay, so when you have a 3-unit class, I think the 16 is actually incorrect. I think it's supposed to be 18. So with a 3-unit class, you're supposed to spend 54 hours in lecture and 108 hours out of lecture per for the entire period of the class. So I did some calculations. So for a 3-unit class, which is very typical for a transfer level class, people are supposed to spend a little bit more than 5 hours per week outside of lectures and outside of lab, to study, review their notes, refine their notes, and so on and so forth. That is expected. Okay, now does it mean people actually do it? Well, I'm pretty sure you all know the answer to that question already. So the next question is it really needed to succeed in a class? The answer is yes. Okay, I am fairly sure it is yes, because I have collected data and I have it's a pattern. Okay, people who actually spend enough time of the class have a higher chance of success. It's not a guarantee, but it's just a better chance of succeeding in a class. Space. Okay, so when you are here, okay, we are all online, but I hope you're in a fairly distraction-free zone wherever you are, because you don't want a whole lot of distraction when you're in class. Structure is kind of important, because that's one thing that gets a lot of people with online classes, especially asynchronous classes, is there's no actual structure. You can go study and read the material anytime you want. It works out for people who are very self-disciplined, and I am not one of those people. If this class was asynchronous, I'll be the first one to goof off and completely forget that I have a class to teach. And I'm not kidding you. And this is why I teach only synchronous classes, because I'll be the first one to forget that I actually have a responsibility to teach a class. Let's see here. Note-taking tool, kind of important, because some people have told me in other classes that they did not know that there's such a thing called note-taking. They just thought if I just sit in front of my computer and have Discord or YouTube open during the entire time that the lecture is going on, that should be enough for me to pass the class. The answer is no. Absolutely no. you have to be actively, kind of participating. You don't have to ask questions or respond to my questions and so on and so forth, but everybody needs to be active during the class. And when you have questions, okay, sometimes I do not explain things really well. Well, in those cases, you need to ask questions using the text channel, in the class server, or you can use your voice if you want to. You can also just direct message me, because I'm also watching out for those if you don't want the entire class to know that you have a question. I really don't think that is an issue. Okay, because a lot of people are shy and they don't want to ask questions in class. For the most part, people really appreciate other people asking questions. So, so feel free to ask questions. And that's it. Okay, I'm just going over this, um, with haste, I would say. So I'm not gonna spend too much time on that. Alright, so moving on to the prerequisite requirements. Math 370 is the old class, and it is Math 372 now. If you took Math 370, it's not going to show up on my roster that you have met this prerequisite requirement. So for people who took Math 370 and got a C or better out of it, please upload your transcript in this particular activity so that I can actually see it. If you took Math 372, it should have shown up already, and I should have given you a point to indicate that you have met this requirement already. CISP440 is a co-requisite, which means you should be taking CISP430 in the same semester as this class, or you have taken CISP430 already. So people who are trying to get into a CISP 430 class, you have until February 2nd to get into a class and show me that you have enrolled in the class. People who have already taken CISP 430 would have gotten a point in this activity already, so that you can tell that I know that you have met this requirement already. Alright, so I just want to pause a little bit and see if there are any questions at this point. Okay. If you had taken Math 400 already, I would have marked a 1 there also, because the tool that the college has provided me has a feature called indirect prerequisite checking. So that means if you have taken any classes where Math 372 is a prerequisite, I would have known about that too. So you might want to check too. You might want to just check, with this activity and see what score you're getting. If you're getting a score of 1, that means I have checked and you're good. All right. Absolutely. All right. Yeah, so you have to turn in a challenge form only if you have not taken Math 372 or one of the calculus classes in one of the Los Rios colleges. But if you have taken Math 372, Math 400, 401, or even one of the physics classes that requires calculus, I would have check that and given you a point there already. So give it a check. If you have any questions, then we can talk about it. Oh, okay. Oh, okay. Okay. All right. Thank you, Danny. I believe that is still the way it works for people who has not taken any calculus or pre-calc class in one of the Los Rios campuses. Alrighty, so we're gonna start with Boolean operators, and you can see, okay, let me get back to the main page on Canvas. So what you see is a little bit different. Let me switch to a student view so it does not cause confusion in this case. So this is the student view, which should be about what you should be seeing as well. Um, don't mind the to-dos, because that's just a whole bunch of stuff that are those are announcements. I sent out a lot of announcements, but when you focus on the modules, I'm just going to go over the modules sequentially, so you can always read ahead of me or the lectures, okay? Because you just move on to the next one, and then the next one, and then the next one, and so on. Alright, so the first one is Boolean operators, which really should not be surprising any one of us because I'm using a lot of the same operators as in your other classes. So there we go. I just have a really weird way of making a truth table. So if this kind of truth table bothers you, it's basically an alternative way of looking at a truth table. Let me just illustrate how to do something like this in Joplin using Markdown. So let me switch to Joplin, and I am going to CISP440 and then make a new note. And Joplin can actually create graphs as well, so that's kind of cool. Alright, so let me create a new note. Control N is the shortcut key to do that. And then I just use today's date as the name of the note. Today is 1/9. There we go. And let me switch back to this view. So in this particular view, the left hand side is the markdown, that's what I type, and then on the right hand side is the rendering in HTML. And I am using the VI key binding too, so it's really cool. I really like the VI key bindings because this way I don't have to use the cursor keys, at least not as much. So my fingers can stay on the home keys almost all the time. Alright, so let's talk about a truth table. So I'm going to use I'm going to say this is a truth table of conjunction, and conjunction is really just a fancy way to say and, where most of you know this as ampersand ampersand. So backtick is how we use a fixed width format, so it stands out a little bit like that. So now I'm going to create a table. To create a table in Markdown is really simple. The first row, you start with a vertical bar. This is the left boundary of the entire table. And then you give it a header. So in this case, with conjunction, you have two independent variables. The first one I'm going to call x. The second one I'm going to call y. And now we want to evaluate x and y. So now we can say x and y. I'm not going to do the fancy thing of using a math equation, not yet. So the second row has to be something like this, vertical bar, to represent the boundary between the columns, and then for the content of the column, using one minus symbol is a minimum to specify that it is a column. And then we can just kind of populate with the value. And one thing you might notice is the minus symbols, they do not have to be aligned with the actual text. So that's kind of cool because this way I don't have to readjust the number of dashes when a column gets wider and wider. Alright, so for x, it can start with the value of 0, y can be 0, and x and y, which is false and false in this case, would also be false. So when you guys are watching this, you probably want to focus on the right hand side, which is the rendered result of the Markdown. Unless you want to learn how to do this in Markdown, then you can also look at the left hand side. And I'm going to get rid of this particular pane here, just so that I get slightly more space for typing. Alright, are there any questions about what I have done so far, or about what 0 means and what 1 means? Just by context, what do you think a 0 is representing and what a 1 is representing? Let me finish this, and I hope this will be more clear once I have done this entire table. Alright, backtick does code snippets in Discord. Yep, it does the same thing in any markdown, but if you don't specify a language, it will try to guess what programming language you're trying to use. So ampersand probably is interpreted as C or C++. Okay, yeah, triple backtick is a block of code where you can actually specify the language, but single backtick is inlined, and I do not think that it has a way to specify what language you're using. I could be wrong. Maybe if you after the second backtick, you might be able to specify the language like this. Let me see. I'm gonna give it a try. Nope, doesn't work that way. Alrighty. Yep. Actually, in Discord you can do it too. In Discord, if you do a backtick and then type something and then another backtick, it's going to look like program code. In other words, it's going to use a fixed size font. Not sure whether it's going to do syntax highlighting. Let me give it a try right here. Nope, no syntax highlighting there. Just using fixed size font. Alrighty. So this is the truth table of conjunction, because we have just x and y. And in my notes, I also give you the alternative representation of and right away, we right here, it's using what looks like a little TP or inverted V. That's the mathematical symbol for conjunction. So it's basically the same thing as ampersand ampersand. And in this class, we have a variety of ways to refer to conjunction. So the first one is what you're used to, which is ampersand ampersand in text. The second one is the mathematical symbol of the inverted V. The third way looks like a multiplication, which is a single dot. And the last one is the abbreviated version of what we understand as multiplication. So XY without even a dot in between is used a lot in electrical engineering documentation. So there you have it. Yep, in C and C++, any non-zero scalar value is interpreted as true. Well, it is the same thing as true because in C at least, because C does not have a bool type, does not have a Boolean type, so the best it can do is to say anything that is non-zero, not zero, is true. So in C++, you do have a bool type, you do have a Boolean type, more or less, kind of. Alright, so these are the different notations for conjunction. So does anyone want to guess why it's sharing the same notation as what we usually understand as multiplication in arithmetics? Why multiplication in arithmetics is using the same notation, or we're borrowing the same notation for conjunction in a Boolean expression? Exactly. So that's very good, Danny. So we are noticing, if you abstract things a little bit, and if we represent false as 0, anything and false and anything is always false. Well, wait, hold on a second here. But that means false is kind of the same thing as 0 in a normal multiplication. And the answer is yes. Well, those two things, even though one is a Boolean and one is a numerical value, one is called conjunction and one is called multiplication, they seem to share certain things. Okay, there's a certain structure to these things where, hey, they kind of behave the same way, in a slightly different context. So you are correct, Danny. And this really kind of leads us to abstract algebra, where yes, don't panic yet. You do not have to take abstract algebra in a 4-year university, okay? But it is a really cool math class because the way it does the way it works is it just abstracts operators and types away, so that you end up with an algebra system that doesn't really deal with very specific values. Okay, it's group, ring, fields, and so on and so forth. Those are topics in abstract algebra. So just a little digression over there. Section 3.2 is disjunction. Disjunction is just a fancy name of or in C and C++, the double bar symbol is basically disjunction. So let me switch back to Joplin, and I am going to, let me see, how many lines do we have here? 6 lines. There we go. And now we change the and to an or, and then the truth table is now adjusted a little bit, because you can see how 0 or 0, false or false is false, false or true is true, true or false is true, true or true is also true. So these are the usual way that we represent a operator using a truth table. The ones that I have used in my notes is a little bit awkward, but I thought at the time that it was a good idea, but turned out it caused more confusion than anything else. So not really exactly a good representation. So if you want to look at a traditional truth table, you can refer to the Joplin representation over here. Do we have any questions about conjunction or disjunction? Yeah, go ahead. Let me go. Uh-huh. Yeah, yeah, right here. Just XY. Yep. So yeah, so those are just alternative ways to represent exactly the same thing. This is used in coding. This is used by mathematicians. These two are typically used by electrical engineers. And then disjunction has alternative representations as well. So if you look at disjunction, and if you replace, okay, let me switch back to the traditional or truth table here. So if you change this or to a plus, then all of these rows will be correct except for the last one, because 1 plus 1 is supposed to be 2 instead of 1. But for the most part, I think you guys can kind of look at this and go like, yeah, I can kind of see how or is similar to addition in traditional just normal algebra and arithmetics. So that is why double bar or disjunction can be represented as a V symbol for mathematicians, but for electrical engineers it is usually represented as just a plus. So occasionally there are times, not so much in this class, but in CISP440, that confusion pops up a lot of times, is so Tech, when you use that plus over here, do you mean arithmetic addition or do you actually mean disjunction? Well, that usually can be resolved by looking at the context. So if the expression is supposed to be Boolean, then the plus symbol means disjunction. On the other hand, if the expression is supposed to give us a numerical value, then we are looking at the usual way of looking at plus, which is addition in that case. So are we good with conjunction and disjunction? Basically and or. Alright, so sounds like everybody is okay with that. So the next one up is negation, which is the fancy word of saying not, right? So in C and C++, the notation is exclamation and then followed by whatever you're negating. Mathematicians like to use this symbol here. Looks like a little dash with a drop. And for electrical engineers, they have two alternative ways to represent this. One is whatever you're negating with an over bar, which is really difficult to type, okay, as you would probably imagine. And then the other way, which is a whole lot easier, is with a slash. So slash x is the negation of x. That can be super confusing because slash is also division, right? So that can be very confusing. So in this class, okay, the way I simplify or make it easier for us to type negation is simply to borrow the notation from C and C++. So exclamation point is the way that I would use to represent a logical negation of a Boolean value. So are we good so far? Any questions? Okay, there are no other questions. So the next, there are two more operators that I would like to, well, actually three more operators that I want to introduce. One is Nand. Okay, so section 4.1 talks about this kind of weird, really weird operator called Nand, N-A-N-D. Don't ask me. I kind of have an idea, but I'm not really sure. Using up arrow as the symbol for NAND, I think this has to do with AND itself is kind of like like an inverted V. So in order to specify that we are negating that AND, that vertical bar is kind of like the bar across. It's kind of like the logo of the Ghostbusters, right? Instead of a slash or a bar that goes diagonally, it is a bar that goes vertically. So I'm guessing that's why they chose this up arrow symbol to mean NAND. But whatever the symbol is, doesn't matter, right? Because it's really just a shorthand. So the idea of NAND is it is a negation of an AND. So x NAND y is really the same thing as the negation of x and y. Alright, so why is this operator of any interest to us? So I'm switching back to Joplin because I'm going to type some examples here. So I'm going to say x NAND y, okay, is basically the same thing as the negation, exclamation point, of x and y, double ampersand y. And let me scroll up so this way you can see the rendering on the other side. Alright, so this is how we define NAND. And you look at this and go like, I don't think we have this operator defined in C or C++. And you would be right. And the question is, so why is this even useful? Why are we even talking about this? So any guesses? Well, as it turns out, this is one of the operators where it is complete by itself. In other words, all of the other operators that we use, okay, can be done using a combination and nested structure of using just NAND by itself. Let me phrase this in a slightly different way. Yeah, exactly. Chris is right. This is all you need. That's the best simplification of the importance of NAND is NOR is the same way too. You just need NOR, and you can basically use it to define all of the other Boolean operators. So it's kind of cool. So let me just kind of illustrate how to use NAND to define things that we go like. So how do you do this in NAND? All right. So let's start with negation of x. So the negation of x is really simple to express using NAND because it is just x NAND x. Because that in return is the negation of x and x itself. Now x and x is really just x. So the negation of x is the negation of x. So that's why we can express what we traditionally know as the negation or the Boolean negation of x as x NAND x. So once this is done, what about x and y, the usual and, not the negated and? Well, that is the same thing as the negation of x NAND y, but we already know how to do negation, so it becomes x NAND y, x NAND y, NAND x NAND y. There we go. What about x or y? So this one is a little bit trickier because, to explain this one properly, I need to kind of give you guys an idea of De Morgan's law. So first, I will do this in steps, okay? So I'm gonna do this in steps and make sure everybody is okay with this derivation. Because double negation cancels out, so if you just have x or y, you can say, well, it's the same thing as the negation of x or y. Do we have any agreement here? Maybe. I'm gonna have to take my. I'm gonna have to bring my little sound effect gadget because it has one sound. That is the cricket. It's really kind of cool. Yep, negative. Double negation is assertion. There we go. All right, so now we're going to apply De Morgan's law. So De Morgan's law, you can sort of look at it as the distribution of negation. So let's go ahead and talk about De Morgan's law just a little bit here. We'll get back to De Morgan's law in the future as well. So we'll talk about De Morgan's law. Let me see if I use it lowercase d. Nope, it just doesn't like it. All right, so De Morgan's law, there are two of them. The one that we need to use here basically specifies if you have the negation of x or y, it boils down to the same thing as not x and not y. All right. So does everybody understand, how to utilize De Morgan's law? Two left turns. No, it does not make a U-turn. Does it? Yes, it does. Okay, so two left turns make a U-turn. Two right angle left turns. Yes. So all right, so in this case, so I got a few things that I want to say, because the first one is it's kind of like distributing the negation to the individual components inside the disjunction, because the negation was applied to the result of the disjunction, but through this transformation, the negation is now applied to each individual component of the disjunction. But then the second thing that is really important to remember is what if it starts with an or, you end up with an and then the companion to this particular De Morgan's law, the other De Morgan's law, says about the same thing, except you start with an and then you end up with an or. So now the next question is about critical thinking. Critical thinking is really important, and I'm going to just use this chance to not to really burst the bubble of people. I certainly hope that I'm not about to burst the bubble of anyone in this class. But I have been asked, okay, I'll put it that way. I have been asked that I should teach to exams. In other words, everything that I teach in class is to get you ready. I'll teach you ways to pass the exams, but that's not my objective. My objective is to teach you stuff that you will find useful in your future classes and in your career as a computer science person. Okay, you can be a developer, you can be an engineer, you can be a security expert. It doesn't matter what you want to become, because all of these skills are important. And there are three things that just about any jobs related to computers would require. The first one is the ability to think critically and to analyze. The second one is problem solving. And the third one, interestingly, is to be able to communicate in written form as well as in oral form. So those three, you can find these three in just about any job description for any type of positions that relate to computers. So now is a chance to talk about critical thinking. What about critical thinking? Well, the first thing is, Tech, how do we know that you are telling us the truth? In other words, the way that I presented De Morgan's law, is that correct? It's possible. I make mistakes occasionally, or a little more than occasionally, but how do you know this is right? And I don't want to hear answers like, but Tag, you are the professor. You're supposed to be right. We don't have to doubt it. Exactly. Test it out. Make a truth table. So how do we make a truth table to test this, right? So let's go ahead and do just that, okay? So once again, let's start with the independent variables. What does that mean? What does the word or the phrase independent variable mean? Okay, so that's the first thing we want to clear up, because to a lot of people, when they listen to my lectures, they think that if they understand what every single word usually means, that they are understanding what I'm saying. That usually does not work, okay? Because independent by itself has a meaning, variable by itself has a meaning, but when those two things are combined, it has a very specific meaning. So what do you think independent variable means? It means those variables, the value of those variables do not depend on each other. Okay? They're independent. Okay? So that means I need one column for x, because now we have two independent variables. X and y are independent variables. So x needs a column, y needs a column. And now we need a column for the negation of x or y. Oops. There we go. And then we need one column for not x and not y. So we need 4 columns for this particular truth table. And then the next row just kind of dictates how we want to format the columns. So if you look up the Markdown language, you can specify center justification, left justified, and also right justified. But for a truth table, that part is not really super important to me, so I'm not going to do that. And now we're going to specify all the cases. So now the question is, how many rows are we looking at? X is a variable, y is a variable. They are independent. Each one is a Boolean type. So we have 2 to the power of 2, which is 4. Very good. So we have 4 rows. We have 0 or 0. We have 0, 0 as one row, 0, 1 as one row, 1, 0 as one row, and then the last one would be 1, 1. There we go. All right. So now we want to, so when you guys are reading this, you probably just want to focus on the right hand side, because otherwise things won't be lining up very well. All right, so when x is false, y is false, the disjunction of x and y is going to be false. Not false is going to be true, so we put a 1 over here. And when x itself is false, not x is true. When y is false, not y is going to be true. So we end up with true and true. So we also have a true over here. When x is false, y is true, then one of them is true already. So x or y is going to be true, but the negation of that is going to be false. And when we look at the negated version of x and y, because they are different, so one of the negations is going to be false, and with an and, with at least one side being false, the entire and is going to be false. So now we have a false over here. This is just the it's symmetric, so it's going to be false, false over here. So when I said symmetric, I basically mean disjunction and conjunction. They are both commutative. In other words, if you exchange the position of the operand, it doesn't change the result of the operation. So now we have 1, 1. So with 1, 1, x or y is going to be true, not true is going to be false. And on the other side, we have not x and not y. Because x is true, not x is going to be false. So that kind of tells me that the entire thing is going to be false. So now that we have a truth table derived, you can look at the column that corresponds to the negation of x or y. You can look at the column of not x and not y, and you can see how they have identical values for every single row, and each row is representing a particular specific case of a value of x and a value of y. So that is telling us that these two expressions are equivalent. They are exactly the same. So this is a very important exercise because one, I'm trying to tell you guys, don't trust me. Okay, you might be able to trust your other professors, but with me, do not do that. Okay, so you want to kind of question everything that I say. But instead of trying to verify everything by Googling, try to use your own methods to verify what I'm claiming. Okay, because that will exercise your own critical thinking skills, and it's not something that people can develop like overnight. It's like, oh, okay, tech just told us about this, and I am suddenly becoming an expert in critical thinking. I mean, I don't critical think all the time, right? So it's just something that you have to kind of try to integrate into your various classes and the way you do things, and eventually you'll get kind of good at it. So getting back to where we left off. Okay, so I'm just going to apply De Morgan's law here. So now we have not x and not y. All right, so now what do we do? So now we have an overall negation. So we just basically reuse the first rule of not x is the same thing as x Nand x. So this time it's going to look kind of ugly because it becomes x Nand x, and then we have Nand y Nand y. So why do we have this, right? So the outer Nand, this Nand here, is because we have a, okay, let me point to this side because it makes more sense for most people to look at it from on the right hand side, right? So this negation here, this negation, okay, I can't really highlight it. There we go. So this negation combined with this and here is this overall Nand over here. And then this negation of x expands to x Nand x. This negation of y expands to y Nand y. So the entire thing becomes x Nand x, the whole thing, Nand y Nand y, the whole thing. Wow. That's that's kind of interesting, isn't it? Because now we can say, even though it is a little bit cumbersome, I'm not saying this is the best way to express logical OR, but it can be done. In other words, in C, C++, and all the other programming languages, they could have just given you one Boolean operator called Nand, and you can do the rest, just as a structured expansion of Nand. My video is covering some of the notes. Yes. Yep. Yes, it is. Alrighty. So let's get back to the notes. Yep, so that's basically the expansion, but I'm kind of explaining why it works. The second operator that we are adding to all the other operators that you are familiar with is implication. So implication is kind of interesting. So the first thing I want to do is to give you the truth table of implication. So once again, we have two independent variables, and this time I'm going to be fancy and use math symbols. So if you want to type in math symbols, you basically just enclose your math expression using dollar signs. And in this case, x implies y is an uppercase right arrow. So that's going to give you the double bar. Oh, it's continuing the previous table. That's not what I want to do. And there we go. All right. So we have x, y, x implies y. So implication is an operator. In other words, we can just define a truth table, and that becomes the definition of implication. So once again, I'm just gonna do some copy and paste here. Too lazy to retype everything. So there are 4 lines I want to copy. Oh, let's make it 5, including this one. And then move down here. There we go. Obviously, we got too many columns, so I'm just gonna collapse some of those columns. Let me show you something that's also kind of cool. You guys are gonna go like, no, Tech, do not show us all this stuff anymore. So you can use a regular expression to replace the last column. So I just want to get rid of the last column. So the way to do this in VI is to use substitution, and you basically specify any character followed by a vertical bar and then end of line, and we want to replace that with nothing. Oh no, it replaced everything with nothing. Or did it work? No, that did not work, did it? Huh. Alright. Alright, so I'm just gonna have to manually do this. It may be because VI is not entirely implemented correctly in Joplin. Alright, so let me get back to here. The truth table is now done, and I have to go back and fix the values. Alright, so let me just put in a space for every single one here, and we'll figure it out one by one. The first row is what is false implies false. What is the value? What is it true or is it false? Okay, false implies false as an expression has its own Boolean value. The question is it true or false? As it turns out, this is true. Yep, that's right. Mohammed is correct. This is true, so is this. This one is false, and this one is true. So now we look at this truth table and go like, well, there are several ways to look at this. The first one is you just look at this and say, okay, this is how we define the implication operator, and no further questions asked. Okay, so that's one way to look at a definition, is simply to say this is the way it's defined and no other questions. Okay, so you just every single time you have to evaluate an implication, you just look up this table and go like, if the left hand side of the implication is false and the right hand side of the implication is true, then the value of the implication expression itself is going to be true. So that's one way to look at it. But most people look at this and go like, but the word implies is bugging me to no end, because I use the word implies, in normal conversations, all the time. And does it make sense that something that is false implies something that is false turns out to be true? So for people who are thinking like that, I have an example. Not necessarily the best examples, but it is one example. So let's just say that everyone in class here pay me $5, to give you guys a statement. Okay, so this statement costs you $5, and the statement says a blue cat is sick implies tomorrow is doomsday. Lost. Oh, okay. So where? Lost where? This is why, personally, I do not like to use pronouns, even though sometimes I do use pronouns. But when people ask questions or make a point in Discord, the use of pronoun can lead to a lot of confusion. Who has a blue cat? I don't care. A blue cat. There exists a blue cat that is sick. But anyway, so the statement is basically saying, if you can find me a blue cat that is sick, then tomorrow is doomsday. That's what the statement is trying to say. Well, I mean, in this case, it's very specific, not anything. This by itself is a condition, right? Because either you can find me a blue cat that is sick, or you cannot. Okay, so this statement by itself can either be true or false. The next statement, which is tomorrow is doomsday, is either true or false too. Even though you can't really, you cannot know it today, but by tomorrow, you can go back in time and say, well, that statement was actually true yesterday, or that statement was false yesterday. So it is still a statement that can be true or false. It's just that you won't know the value until tomorrow. You have to kind of go back to the past and say, yesterday when I said that, okay, that particular statement is true or false. So we have 4 cases here. So in this case, the first one is basically saying, yes, I did find a cat that is sick. and then tomorrow turns out to be doomsday. So from the perspective of tomorrow, you can now say, well, this statement was true yesterday. Is that okay so far? Does everybody understand what I just said? So looking back at yesterday, you said, I was able to find a blue cat that turns out to be sick. And yesterday, we claimed that tomorrow is doomsday. So from the perspective of today, which is doomsday, that statement, both statements were true. So in that case, do you think you can get that $5 back? Get a refund because I told you a lie. I told you a statement that is not true. The answer is no, you cannot get your $5 back. Now, not that $5 is going to help you in any way, because remember it's doomsday anyway, but you cannot get the $5 back. You cannot get a refund. So what about the second one? The second one is saying, from the perspective of tomorrow, yesterday I wasn't able to find a blue cat that is sick. And yesterday, I did not make a claim that tomorrow is doomsday. So in this case, can you get your refund of $5? Well, you cannot, because the statement that I gave you, costing you $5, does not say anything about what if a blue cat is not sick. That is the whole thing about implication. Okay, the precedent, which is basically the first part of the implication, if this is false, then you cannot say the statement itself is false, because this statement is only saying something about the condition when the precedent is true. It doesn't say a single thing about what happens when the precedent is false. So that's why, if you could not find a blue cat that was sick yesterday, then doesn't matter whether I claim tomorrow is a doomsday or not, you're not going to get your refund back. So if x is true, then we use y, and otherwise it is true. Yes, Chris, that's one way to express it. I'll give you guys another way to express it, but what Chris put into the text channel is correct, using a ternary operator. That's actually pretty smart. I have not thought of that. So when can you actually get your refund, right? So from the perspective of today, if yesterday you were able to find a blue cat that was sick, and today is not doomsday, then you can come to me and go, Tack, according to your statement, today should be doomsday because I was able to find a blue cat that was sick. And yet, here I stand, nothing happened. I want my $5 back. Yes, so in that case, I'm going to have to refund you those $5 because what I said did not happen. So is that okay? Does everybody understand how the word implies or implication is used in logic? All right, very good. So other than what Chris has put into the text channel using a ternary expression as an alternative way to define implication, there's another way to define implication. So I'm going to use Joplin to denote that. So I'm going to put in here for implication, x implies y can also be expressed as, and I'm going to use the mathematical notation here. So it is the same thing as the negation of x or y. So this negation applies to x and x only. So the negation of x, okay, let me put in some extra parentheses to make it very, very clear. So let's open, and here is the close. So there we go. So x implies y can also be expressed as the negation of x or y. So that turns out to be the same what Chris has put into the text channel of using a ternary expression, x question mark y colon 1. All right, Luke is typing something in the text channel. I'm going to wait. And I got some DM stuff going on. Let me check that. Oh, okay. Oh, okay. I see. I see what Chris is saying. My face is covering some of the Joplin notes. Okay. If there is no gas, then the car won't run. So there's a lot of negation here. So let's check that statement. Okay. So if there's no gas, then the car won't run. So the only time when the implication is false is when there is no gas is true, and the car won't run is false. So you have no gas in the tank, and yet the car runs. That would be the only time that makes the implication itself false. Otherwise, the implication is true. Yep. Yep. But in this case, it's always true. In other words, just based on the mechanics of a regular car, that statement is always true. Whereas in my example, you're asking when can I get my $5 back? In other words, the statement itself can be false. And I think it's important to understand that the implication itself as an expression can be false. That is the most important part. And just because there's gas doesn't mean it will run. Yeah, but the statement is still true. So even though you have gas in a tank and the car doesn't run, the statement is still true. Yep, exactly. So now I'm going to kind of switch into the meta knowledge part. Okay, so this is the knowledge about gaining knowledge or how to apply knowledge. I'm pretty sure from the text traffic, some people really are getting what implication means. Okay, but there might be people. I'm not saying those people are in this class, but there might be people saying, I kind of know what implication means, and I think I'm good. Well, my recommendation is no. There's no sort of. Okay, as Yoda said, do or do not. Okay, you gotta make sure that you understand the meaning of implication. So you can always just go back to the truth table. Just look at the truth table and use the truth table to tell you what the value of the expression is based on what is on the left hand side and what is on the right hand side of the operator. You can always do that. You can always go back to re-expressing implication using operators that you are used to. But it is super duper important to use one of these two ways to look at implication, because there are a lot of topics in the rest of this semester that really makes use of the definition of implication. So if the understanding of implication is not solid, teach you I will. Okay, so I got something about Yoda speak too. Yoda speak is postfix. Is postfix notation. You basically in postfix notation you specify what you're operating on first, and then you specify what operation you want to use to operate on those things. So since somebody posted that, I'm gonna give you an example. Yes, I'm digressing here, but it is something that's actually quite interesting and useful. So if the original expression is 1, okay, let's not use constants because it doesn't really help. Okay, so we have x plus y, the whole thing times z. Okay, so this is really just regular arithmetics. So if this is the infix notation, then the postfix notation, in this case, there are several ways to specify that, but it's xy plus and then z times. So that's kind of Yoda speak, because you specify you specify the objects first, and then you specify what action is going on between the objects. Teach you I will. Maybe not, because in that case it's going to be UI teach will. There we go. All right. So this gives me an idea to write a program to convert every English sentence into Yoda speak. Different notations. What do you mean by different notations? You mean the infix notation versus the postfix notation, or are you talking about the actual topic of this class? Oh, the postfix thing? Not so much in this class, but if you are taking or if you have taken CISP440, you probably should know about postfix notation, because that's how we express things in that specific assembler. Anyway, we got one more operator before we are done with this module. I'm looking at the time. We are doing well in time. I'm going to take roll in just a few minutes. Alright, so this is the last one. The last one is equivalence. So equivalence is kind of like a double-sided arrow. So x is equivalent to y is basically the same thing as x implies y and y implies x. So you can see how the operators are stacking up, because we just introduced implication, and we are using implication itself to define what is equivalent to or equivalence. So there we have it. I'm going to take roll now, and then we can get back and take a look at what we are going to talk about on next Monday. And I will also give you guys some recommended activities you can do over the long weekend. Alright, so the way I take roll, some of you know this already, and some of you are new and may not know how I take roll. So the way I do it is I use a form. I take roll in the form of a quiz, but it's not really a quiz. It doesn't really count to your grade. So roll taking, this is 2022-01-19, and then I go to the questions, and I'm going to go pick up a word that is right on my mind now. Let's say Yoda. Okay, so Yoda in uppercase and Yoda in lowercase. So if you type in Yoda as the answer to this fill in the blank question, then you are in class. You have provided me with evidence that you are in class. So let me go back and fix the time. So so I usually give people a 10-minute window to participate in this activity. So let's see. Alright, so today is the 19th. And the time is 03, so I can give you up to like 14. So 1:14 p.m. January 19th, 1:14 p.m. Save and publish. And so if you refresh your window on this canvas page of this class, then you should be able to participate in the roll taking activity and just type in Yoda. I typically would also type in the word in Discord, so this way people can just copy and paste in case they cannot spell Yoda. Oh, answer didn't save. Oh, that's because I forgot. You got it wrong? I think it's because I didn't save it. Yeah, that's okay. I'll go ahead and fix it because, okay, I will tell you what mistake I made. This is the other thing about, remember what I said about problem solving and critical thinking? So instead of being pissed off and go like, shit, I don't know what just happened. Well, it's important to kind of stay calm and not to judge yourself. Okay, as stupid as I might have appeared to all of you, it is much more important that I find out, so what did I do wrong that caused this problem, right? So I will show you exactly what I did wrong. So when I made a change, okay, it's still class in this. So when I change it to Yoda and Yoda here, I forgot to click update question. In other words, if I made changes over here and I just click save, it did not. That doesn't save the changes to the question itself. It saved all of the other settings to the question, but it didn't save the change to this specific question. I really should have clicked update question first, then click save over here. So there are two things I need to do in when I change the answer to the questions. So I'm just going to go back and anyone who answers anything is going to get a point. This is not a big class. It's okay. With my other class, it's going to be time consuming. With this class, it's not so big of a deal. All right. Well, the thing is, we all make mistakes. It is inevitable that we make mistakes. So the key is to learn from the mistakes and not to get pissed off because of the mistakes. And the first thing is, just don't care about what other people or yourself, is going to look at the mistake. You just learn from it. It's a learning opportunity. So that's really important too. Actually, I'm not gonna. Okay, let me finish what I really wanted to do first, and then I'll get back to this line of reasoning because I think it's really important in the long run. All right, so on next Monday, we're going to get started with basic set theory. So this is one thing that I think everybody should do if you have the time, because we got 5 days before we meet again on next Monday. So it is a good thing to review what we have talked about today with Boolean operators, specifically the things that are new to us. Okay, Nand, I'm not too worried about it. I threw that in just because it's kind of cool. But implication, it's kind of important. Okay, how a truth table works is really important. And then the definition of equivalent to or equivalence is also important. So I'm going to start my own notes. Okay, I'm going to have a section of my notes dedicated to definitions. So I'm going to have a definition of and you might say, but we already understand and. Well, what about all the notations, right? All the ways to represent and. Oh, it can be seen as ampersand ampersand. It can be seen as a inverted V symbol. It can be seen as a dot, like in multiplication, or it may not even have a multiplication symbol between the two variables or expressions that are being ANDed together. Those are the notations. Same thing for disjunction, okay, right? Because it can be double bar. It can also be a plus. Negation, it can be an exclamation point, can also be an over bar, and also be a little cliff symbol. So I'm going to consolidate all of those definitions and symbols in one part of my notes. Okay, and this is where having an electronic note-taking mechanism is helpful, because you can just kind of copy and paste all the notations to one part of your notes. So this way, when we reuse these notations in the future, you can look it up. If you have forgotten anything, you can just look it up really quickly. But I would also recommend all of you to start reading basic set theory and jot down any questions that you have about those concepts. If I do not address those concepts correctly, sufficiently on Monday, then you probably want to ask me in class. It's like, okay, I read this, but I'm having some questions about what this actually means. So that's really important. Reusing make me sluggish. Taking notes by hand on paper again. That's up to you. Okay, everybody has a different way of taking notes and reinforcing what you have learned. So just do whatever works best for you. But I think in addition to taking notes during class, it's also important to spend some time to review the notes. Okay, to kind of go over again, to summarize, and also to try to connect what you have learned in the previous class with everything else that you have already learned before, because that is understanding. It's the connection between the concepts. Okay, that's understanding. Very good. Okay, so let's get back to the thing about making mistakes and learning from mistakes. So this is a little bit about psychology, and I'm definitely not an expert in psychology, but I know enough to be dangerous. When people are upset because they have made a mistake, the first thing people do is they shame themselves. And this happens because depending on our childhood experience, obviously, but for some people, when they were children and they make a mistake, parents or teachers or other figures of authority sometimes would use shame as a tactic to try to deter the child from making more mistakes, right? So those people learn that making mistakes is quote unquote shameful, and over time, that becomes, they integrate it, they internalize, that judgment. So when they look at themselves making a mistake, the same thing happens because, the critic is no longer coming from outside, but now it's coming from inside. When we want to learn something, having these negative emotions of shame and whatnot is very, very counterproductive. So the first thing we want to do is to stay calm and go like, okay, so what I expected to happen did not happen, because that's factual. Okay, that's just the facts. Okay, I was expecting Yoda to become the answer for the role taking activity, and it did not. Okay, you guys told me no, that didn't work. So focus on the facts. Okay, it's just the facts. Okay, there's no judgment. And then the second thing is to look at it from the perspective of curiosity. In other words, instead of getting pissed off, getting ashamed, you go like, I wonder how that happened, right? Because that is, it basically stops the negative emotion from happening, or at least it kind of keep it at bay. And then the more important part is it's starting your troubleshooting or your analysis path, so that you can get started with the troubleshooting mechanism. And the more you troubleshoot, the more your brain is used to, analyzing a problem, analyzing why is there a difference between what I expect to happen and versus what actually happened. Because when you work as a software engineer or as a software developer, guess what? You'll be troubleshooting almost all the time. Okay, when you get in as a beginning developer, what do you think you're going to do? I'm asking a general question. When you get a job as a developer, as an entry-level beginning developer, what do you think will be some of your first assignments? Documentation. Exactly. So documentation is one, okay, but documentation is kind of interesting because a lot of times, most companies cannot keep up with documentation these days. But bug fixes is one of the first things that you would probably do. This is the equivalence of having someone to give you a toothbrush and say, go clean up that bathroom. That's usually what you will end up doing as a beginning developer. And that involves a lot of, guess what I just said, critical thinking. The program is not doing what we think it should be doing. Why is it the case, right? And that's why, I would try my best, okay, to kind of encourage all of you and also kind of tell you how I do it. It's really hard to kind of dissect my own thinking process, but I'll try my best. And because I want you guys to also kind of develop the skills to to analyze, to think in a critical way, and also to problem solve. Passing this class with whatever grade is really not that important in the long run. Okay, in the short run, yes. Okay, I'm not negating the importance of going to school and getting a good grade. It is important, but in the long run, it is the skill set that you're acquiring along the way that is important. Your grade is important only maybe, okay, even maybe for your first job. After that job, you're moving on, you're trying to apply for another job. Your grade is not that important anymore. Yeah, code testing is important too, so Manpreet is correct. But code testing, how do you test code? Okay, so let me ask you that question. You have an application of some kind, right? So how do you design the tests for that particular application? That is still an analysis process, right? Because you have to look at the specification of the software, and then you ask what kind of input is supposed to be valid, to get into this program, and more importantly, How do I test this program for things that are not supposed to be valid as input? What am I supposed to see as the output? Am I supposed to see a warning, an error message, or is it supposed to be logged, and so on and so forth? It is a very analysis-based process. And CS get degrees unless you're going to grad school. Oh, Cs. Okay, I look at CS and go like Cs. A lot of employers really do not value GPAs and which school you graduate from anymore, thanks to COVID. Okay, thanks to the pandemic. A lot of people have been taking classes online and being rewarded by degrees. They're basically online. Now, I'm not saying anyone in this class is dishonest, but there are a lot of people out there who are much more focused on, I need to get a degree from this really well-known university and I need to have a GPA like this, okay? And some of those people are dishonest, right? They cheated, and by the time they get to a job interview, these companies basically go like, okay, initially they're gonna go like, oh, you graduated from this really well-known university with this GPA, you have to be good, okay, you have to be competent with what we expect you to be able to do. And then these people get into the company and that turned out not to be true. So the employers are now getting smart, okay? They basically do not value which school your people are graduating from, nor the GPA, not that much anymore. In your job interview, they will give you a technical test, okay? In other words, they have their own little entrance test that are actually quite challenging. You can find books on Amazon about these kind of technical questions that Google, Facebook, Pixar, would tend to ask, for the candidates. And they keep changing it, obviously, because once it's published, hey, we're gonna have to change it so that people cannot come prepared just because they have read a book. So employers are already doing whatever they can in order to assess the ability of people to think critically and to problem solve. And that's why it is much more important that you learn all of these skills before you get to apply for your first job. So it's just me doing my little lecture here. I know it sounds really boring, but I think that's the reality. And guess what? You guys have to face that reality. I'm just gonna retire at some point. All right, so that's all I have for today. Remember, we have a long weekend, 5 days. So do the review of your own notes. Read ahead of me. For those of you, some of you probably have some experience with basic set theory already. You can keep going, right? After this, we have basic quantifiers, and then after that, we have re-explaining set theory using quantifiers and so on. So you can go as far as you can, just reading ahead, as far as you want to. But the minimum, to be productive in the class is to go over at least basic set theory. All right, so we got a few text traffic here. Am I going to publish that? Sure, I can. It's not anything that's really kind of I didn't think of it as very important, but I can certainly do it. So I will show you guys how to do that too. All right, so let me get that back like that, and right click, export to HTML file. And this part you cannot see because it's off the screen, but I will put it into my temp folder and then upload it through the text channel. Right. So it's important that you guys also learn how to take your own notes. Okay. I'm not gonna type everything. As I talk about things, not in general. So this is just an illustration of me taking notes, and there you have it. It's an HTML document, by the way. It's kind of big as an HTML document because I think it includes a whole bunch of cascading style sheet stuff and JavaScript stuff, because it's quote unquote self-contained. So so that's it. Anything else? That is correct. There's no textbook because most of the material of this class, can be found. I basically type all my notes. Basically that's your at least the starting point of your reading material. But there is no concept that we're going to talk about in this class that really demands a textbook because you can always just kind of look it up on the internet, for explanations. There are certain derivations here that are my own, but those are usually not super duper important. You're welcome. Oh yeah, yeah, yeah. I have been doing this for all of my classes. No textbooks. Just based on my own writing. It's good from the perspective of you don't have to spend any money. But it's bad from the perspective of I don't have an editor. I'm not a publisher. I don't have editors, so my notes can be filled with typos and whatnot. And if you guys let me know of typos and mistakes and whatnot, I can fix those almost as quickly as you guys can, tell me about it. So that's one thing I can do. All right, so we have some recommendations. Yeah, I'm aware of Obsidian. It has kind of the same thing where you can use Markdown. Yep. And also LaTeX, which is basically what I used to type in the math equations. I really like Joplin because it's very lightweight. I'm not sure about Obsidian. I have not tried Obsidian. Let's see. Yeah, so the rotating thing is all good. I made a mistake. I forgot to click update question. So anyone who put in an answer, within that time frame, is going to be marked as present. So don't worry about it. Yeah. Yeah, so you guys can do the same thing too. So as you take notes for this class, as I said, put all the definitions, all the symbol definitions, and all the term definitions in one place. So that way, when you are in exam 1, exam 2, or the final exam, and you need to just kind of get a quick confirmation of something, you don't have to search through all the modules that I have written. You just have to go through your own notes, go through your own definitions and go like, okay, yeah, okay. As I thought, that symbol means blah, blah, blah. And I think that's important. It's a good habit to build up, for those people who have not been taking notes. There we go. Are the quizzes, assignments, or exams going to be during lecture? Yes. So the truth is, I don't do quizzes, okay? And assignments are homework assignments, so those are done, in your own time. So only the exams are during lecture. So I hope that answers that question. Duffer Publishing makes really good cheap books. I grabbed Discrete Math book for $12. It's really dense and it goes through the material really fast. One more thing, if you are not familiar with note taking, you can start with Cornell Notes. Okay, Cornell as in the university. So they have a Cornell Note system which is kind of visual. You chop up a page of paper into an area where you just kind of log what you hear and what you see during the class, and then on the left hand side you make a quick summary right after the lecture, and at the bottom you make a much more thoughtful summary of what that page of notes is really saying. So it's kind of like a increasingly deepening understanding of the content, but using a very kind of visual way to do it. So Cornell Notes is something that some of you may want to look into. IDE, Integrated Development Environment. I'm not sure what IDE is doing in the question. Yes, Nathan is correct. I am using the Joplin app from joplinapp.org. It's also open sourced. I have already started to make some changes because of syntax highlighting. Okay, so I would like to syntax highlight my own TTP-ASM. For those of you who took assembly from me, you know what I'm talking about. So I made some changes so that the source code would be highlighted correctly in Joplin 2. It's really kind of fun to go through open source projects. You just want to add one little feature, and then you have to read a whole bunch of code just to figure out where you need to make that change. And that's analysis. It's a really good application of problem solving and critical thinking. Alrighty. Oh, you guys can choose whatever you want. The program that you will be writing, there's only one little program that you need to write in this class. You can write it in C, C++, or Java, or Node. But the Node is going to be, it has to be self-contained. I don't use an IDE for anything. Okay, unless you count VI as an IDE, I don't use an IDE for anything. I can even do Markdown using VI. So it's your pick. Okay, if you want to use Visual Studio for stuff, go ahead and use it. You can even use Visual Studio to type, to type in Markdown. On the other hand, if you just say I can use Notepad, Notepad is fine. There's nothing wrong with Notepad. Or if you want to say, but I want to kind of visualize the equations and whatnot, then you can use Joplin or Obsidian. So there's a whole bunch of tools you can use. I know class time is over, so for those of you who want to kind of get out of the class, you can do it. But I want to show you this one thing too. And let me find that. Find the right command line interface because I got a whole bunch. This one here. Okay, so let me show you what I can do with VI. So if I do a VI or Vim, NVim for Neo Vim, Neo is new, right? And then VI is visual. Vim is actually VI improved. So this is like the abbreviation of a whole bunch of stuff kind of wrote into 4 characters. So if I just do something like this, okay? So MD is Markdown, and press the Enter key. It opens up Firefox as a preview window, and I think this will work. Okay, so let me just do this. It can do a preview, so this is a bullet list. There we go. And I can also use equations. Let's try dy over dx, like that. So it's a really kind of nifty tool because it links the content inside Vim or VI to a renderer, that will keep rendering the markdown into HTML. So it's another way to take notes, right? There are, whatever works for you, use it. All right. So so I got a few questions. So for those of you who don't know what Chris is referring to, Ed is the predecessor of VI because Ed is what we call a line editor. VI is visual. It was already a huge step forward. And then Sebastian said, so the co-requisite of this class CISP440, that's data structure. Yes, that is correct. All right, so Sebastian, if you have taken CISP430 but not from within the Los Rios district, then you will have to file a prerequisite challenge or co-requisite challenge form in this case. It's the same form, okay? Co-requisite, prerequisite, it's the same form, but you're going to have to file that form with the division office and upload a copy of your form using the activity that kind of tracks who has met that requirement. So this way I know the process is in progress, and I won't drop you. So is that cool, Sebastian? Do you know what to do? We can chat offline if you need to. All right, so I think that's it for today. So once again, I'm going to send you guys, kind of a list of things for you guys to think about, just a bunch of questions that you might want to be able to answer, okay? But I will do this for maybe 1 or 2 classes, but not for all of the classes. But I'm doing this just to show you guys, what you're supposed to understand, after a class and what kind of question you might want to ask yourselves after a class. That's it. Okay, well, thank you for coming here and staying with me, for this class during this time, and I will see you guys next Monday. Have a nice long weekend, and if you need to contact me for anything, just ping me on Discord and I'll get to you as soon as I can. Well, okay, I shouldn't say that, but within 24 hours. Within 24 hours. There you go. All right, so I'm going to stop the streaming.